Welcome back, everyone, to the Deep Dive. Ready to explore some more fascinating stuff in the world of data?
Always.
Awesome. Today, we're diving deep into the modern data stack, specifically focusing on an emerging database that's been making some waves.
Ooh.
DuckDB.
Hmm.
Have you heard about this one?
I have. Yeah, DuckDB is getting a lot of buzz lately, and for good reason.
Yeah, seems like everyone's talking about it. And our listeners, you send in some really interesting material comparing DuckDB to building a similar data stack on AWS.
Sounds like someone's trying to figure out the best way to wrangle their data.
Yeah, maybe they're working on a project. Maybe it's for work. Or maybe they're just curious like us.
Well, whoever they are, they've come to the right place. The modern data stack can be a bit of a jungle.
It can. And expensive.
Oh, yeah, for sure. That's one of the things that makes DuckDB so appealing. It's known for being really efficient and surprisingly powerful.
Yeah. And speaking of appealing, one of the sources we dove into actually calls DuckDB the Swiss Army knife of analytics.
Oh, okay. I like that. That's a pretty bold claim.
It is. And they highlight a few key things about it. They mention its speed, the fact that it's super easy to set up, like no configuration needed, and its ability to work with all those modern data formats, like Parquet.
Yeah, Parquet's a big deal these days, especially for big data.
Totally. But there's one thing I keep seeing pop up that I'm a little fuzzy on: in memory. What does it actually mean for a database to be in memory?
Ah, good question. In-memory basically means that the database primarily operates in your computer's RAM. So instead of relying heavily on slower disk storage like traditional databases, it keeps everything it needs in RAM, which is like a super fast workspace.
Okay, so it's all about speed.
Gotcha.
That makes a lot of sense why they keep mentioning it.
Yeah,
So I guess if you're dealing with a lot of data and you need things to run quickly, DuckDB could be a game changer.
exactly. It's designed for speed and efficiency. Think of RAM as your short-term memory and disk storage as your long-term memory. RAM is way faster for accessing information quickly. So DuckDB keeps the data you're actively working with in RAM ready to go.
Okay, I'm starting to get the picture. But how do you actually get data into DuckDB in the first place? Like, where does it come from?
Well, you've got a few options. You can import it from files, connect to existing databases, or even query data directly from cloud storage like S3.
Wait, hold on. You can query data straight from S3.
You got it. It's one of the things that makes DuckDB so cool. It cuts out a lot of the complexity and cost of traditional data pipelines.
That's super useful, especially if you're already storing tons of data in the cloud. Do you have an example of what that would look like?
Yeah, actually, one of your sources gives a great example. They show you how to count all the records in a CSV file stored on S3. It's a simple query, but it demonstrates the power of being able to access data directly from the cloud.
Okay, so no more downloading huge files and importing them into a database. That's a huge time saver.
Exactly. And it opens up a lot of possibilities for working with data that might have been too cumbersome or expensive to deal with before.
I'm starting to see why people are so excited about DuckDB. So let's say we've got data flowing into DuckDB. What's next? How would you actually build an entire analytics platform using it? Where would you even start?
Well, your sources outline a pretty practical approach. Think of it as a series of steps. The first step is data ingestion.
Right.
That's all about bringing raw data into your DuckDB environment.
Okay, makes sense.
Yeah.
But isn't just dumping all your data into DuckDB going to create a mess? How do you keep things organized?
That's where incremental loading comes in. Instead of reloading everything every time, you only add the new data that wasn't there before.
Ah, so if you're pulling in daily event data, for example, you'd only add the events from that day instead of reloading all the events from the past.
Exactly. It's way more efficient, especially if you're dealing with data that's constantly being updated.
Okay, that makes sense. But what about data quality? How do you make sure the data you're bringing in is actually good?
That's a crucial step. Your sources talk about implementing data quality checks during ingestion. They give an example of creating a view that checks for things like record counts and data latency.
Okay, so if you're expecting a certain number of records and you suddenly see a huge drop, that would raise a red flag.
Exactly. It could be a sign that something's wrong with your data pipeline and you need to investigate.
So it's like a built-in alarm system for your data.
Mm-hmm.
I like it. So we bring the data in, check it for quality, and then what kind of cool analysis can you actually do with DuckDB?
Oh, this is where it gets really fun. Your sources dive into building a customer 360 view using DuckDB.
A customer 360 view. Okay, I'm intrigued.
It's all about getting a complete picture of your customers. Imagine you've got customer data scattered across different sources. First touch points, engagement metrics, preferences, purchase history, all that stuff.
Yeah, that's a pretty common problem. It's like trying to solve a puzzle with missing pieces.
Exactly. And DuckDB can help you put that puzzle together. Your sources show how you can use DuckDB's SQL capabilities, including some advanced features like window functions, to pull all that data together and segment customers based on their lifetime value.
Hold on, window functions. That sounds a little intimidating. Can you break that down for us?
Sure, window functions are basically a way to perform calculations over a specific window or range of data within your SQL query. So let's say you want to calculate a 30-day moving average of your sales data. A window function lets you do that right within your query without having to create separate tables or do any crazy joins.
Okay, so you're basically performing calculations on slices of your data. That sounds pretty powerful.
It is. It opens up a lot of possibilities for analyzing trends and patterns over time.
This is all starting to make sense. So you can pull in data from different sources, clean it up, and then use DuckDB to really dig into the data and answer some interesting questions about your customers.
Exactly. And because DuckDB is so fast and efficient, you can do all of this really quickly. It's like having a superpowered data analyst at your fingertips.
This is blowing my mind. So DuckDB is fast, efficient, and it can handle some pretty complex analytics. But even with all that power, don't you still need to worry about performance optimization?
Absolutely. Performance is always a concern no matter what database you're using. But your sources have some clever tricks up their sleeve. They talk about using a technique called materialized views to speed things up even further.
Materialized views. Okay, you're going to have to explain that one too.
Think of it as a pre-computed result saved within the database. So instead of recalculating a complex query every time you need it, you just access the pre-computed result from the materialized view. It's like having a cheat sheet for your most common queries.
So it's all about saving time and making things run faster. I'm starting to see a pattern here.
You got it. And the sources go even deeper. They outline a robust refresh strategy for materialized views to make sure the data is always up to date.
So you're not stuck with stale data.
Exactly. They talk about incorporating backups and validation checks to make sure everything is fresh and accurate.
That's impressive. It sounds like they've thought of everything.
Yeah.
So we've talked about getting data into DuckDB, cleaning it up, building cool analytical views, and even optimizing performance. But can DuckDB play nicely with other tools?
That's a great question. And the answer is a resounding yes.
Music to my ears. I mean, what good is a database if it can't talk to anything else?
Exactly. Your sources actually provide a Python code example that shows how you can use DuckDB to query data and then use popular Python libraries like Pandas and Plotly for further analysis and visualization.
So you can use DuckDB for the heavy lifting of querying and manipulating the data, and then bring in other tools for their specific strengths.
You got it. It's all about using the right tool for the job.
I like that approach. So no more trying to force one tool to do everything. It's about building a flexible and efficient workflow. Speaking of putting everything together, your sources walk through building a complete e-commerce analytics platform on DuckDB.
It's a really common use case. And it's a great way to see all of these concepts come together in a real-world scenario.
So they show you how to create all the core tables like
Yeah.
products, users, orders, all that stuff.
Yep. And then they build out an analytics view for product performance. So you can calculate things like revenue per customer, average selling price, all those key metrics.
That's awesome. It sounds like a really practical example of how you can use DuckDB to build something really valuable. This deep dive is giving me a lot of ideas for how I can apply DuckDB to my own data challenges. But there's one elephant in the room we haven't addressed yet.
Uh-oh. What's that?
AWS. I mean, it's the 800-pound gorilla in the cloud space.
Ah,
How does DuckDB stack up against all the services AWS has to offer?
that is the million-dollar question, isn't it?
Yeah.
It's a tough one. AWS has a massive suite of services, and they're definitely great for certain use cases. But the real question is, what's the best fit for your specific needs?
Right. It's not a one-size-fits-all situation. So let's break it down. The source material actually mentions a whole bunch of different AWS services. They talk about Redshift for data warehousing, RDS for managing relational databases, Athena for querying data directly in S3, EMR for big data processing with frameworks like Spark.
Don't forget Aurora Serverless.
Yeah.
for those workloads that go up and down like a roller
Oh,
coaster.
yeah, good catch.
Yeah,
And DynamoDB, which is a NoSQL database. So many options.
right. AWS definitely gives you choices, which it can be a good thing and a bad thing sometimes. It's great to have options, but it can also be a bit overwhelming to figure out what you actually need.
Yeah, I can see that. So how do you even begin to compare all of these different services? What are the key things to consider?
Well, one of the sources sums it up really well. They say the best choice depends on three main factors: your workload, your scalability needs, and whether you want a fully managed solution or a database embedded within your application.
Okay, that makes sense. Let's unpack those a bit. Starting with workload. If you're dealing with massive data sets and you need to run really complex queries, a service like Redshift might be a good fit. But what about DuckDB? What kind of workloads is it best suited for?
DuckDB really shines when you need that in-memory performance for fast analytics, especially if you want to embed the database directly within your application.
So like real-time dashboards, interactive data exploration, things like that.
Exactly. Or even running analytics within a Python script.
Now that you mention it, one of the sources actually claims that DuckDB's query performance can rival or even beat Redshift for certain analytical workloads. Is that really true?
It can be, especially for queries that benefit from DuckDB's in-memory architecture and columnar storage. It's not that one is inherently better than the other. It really comes down to understanding the strengths and weaknesses of each tool and choosing the right one for the job.
So it's all about trade-offs. Redshift might be better for handling huge data sets at scale, while DuckDB could be faster for specific analytical queries on smaller data sets.
Exactly. It's all about choosing the right tool for the right job.
Makes sense. Okay, so we've talked about workload. What about scalability? That seems like a major advantage for AWS. They're built for handling massive amounts of data.
You're absolutely right. AWS services are designed to scale like crazy. So if you anticipate explosive data growth, you might lean towards AWS.
So what if I start with DuckDB and my data needs grow? Am I stuck?
Not at all. Even with DuckDB, you have options. You can partition your data across multiple DuckDB instances, essentially creating a cluster for higher throughput.
So it's like building your own mini data warehouse with DuckDB as the engine.
You got it. And if you need even more power, you could explore integrating DuckDB with distributed processing frameworks like Apache Spark, which can handle absolutely massive data sets across a cluster of machines.
So even though DuckDB is a single node database at its core, there are ways to scale it out if you need to. That's pretty impressive. Okay, let's move on to the last factor, managed versus embedded. What does that even mean in this context?
Well, think of it this way. With a managed service like Redshift or RDS AWS takes care of all the nitty-gritty details for you. Infrastructure backups, maintenance scaling, all of that. It's pretty hands-off, which can be a huge time saver. But you do pay for that convenience.
So it's like the difference between renting an apartment and owning a house. With renting, someone else takes care of the repairs and maintenance, but you have less control.
That's a great analogy. With DuckDB, on the other hand, you have more control. You can embed it directly within your application, which gives you tight integration and more flexibility in terms of configuration.
So if I want simplicity, and I don't mind letting AWS handle the details, I might go with a managed service.
Yeah.
But if I need more control and I want to really fine-tune things, I might go with DuckDB.
Exactly. It really depends on your priorities and your comfort level. Some people love the idea of having AWS handle everything, while others prefer to have more control over their setup.
It sounds like there are pros and cons to both approaches. This is giving me a lot to think about. It seems like these sources are making a strong case for building a modern data stack with DuckDB. But what about the future? How do you see all of these technologies evolving? I mean, technology moves so fast, it's hard to keep up.
It really does. But your sources do highlight a few interesting trends. They mention that in-memory databases like DuckDB are starting to incorporate machine learning capabilities. Imagine training and executing machine learning models directly within the database.
Wow, that would be a game changer. No more moving data back and forth between the database and your machine learning tools. That would be a huge efficiency boost. What about AWS? They're always innovating. What can we expect from them in the future?
Oh, they definitely are. I think we'll continue to see advancements in cloud database management, serverless technologies, and the integration of AI and ML into their services. The lines between traditional databases and cloud-based solutions are definitely blurring.
It sounds like the future of data is going to be pretty exciting. But before we get too carried away, let's bring it back to the here and now. What's the best way for our listener to start exploring DuckDB? What's a good first step?
I think the best way to really understand a tool is to just dive in and start using it. Get your hands dirty.
So maybe take a data set that I'm already familiar with and try to answer some questions using DuckDB.
Exactly. Pick a specific problem you want to solve and see how DuckDB handles it. Don't overthink it. Just start experimenting.
Keep it simple, right? I have a tendency to over-engineer things sometimes.
I think we all do, and that's actually a good point to bring up. One of the things your sources emphasize is the importance of starting simple and building up your solution gradually.
So don't try to boil the ocean on day one.
Exactly. Start with a small proof of concept and add complexity only when you need it.
That makes a lot of sense. But how do you make sure your DuckDB queries are actually running efficiently? I mean, we've talked about how fast it is, but there's always room for optimization.
Yeah. Oh, absolutely. And your sources have you covered there too. They show you how to use views to monitor the performance of your queries.
So you can track things like execution time and resource usage.
Yep. It's like having a performance profiler built right into the database.
That's super handy. You can see exactly what's happening and optimize accordingly. But what if I run into limitations? What if a single DuckDB instance just isn't enough to handle my data or my queries?
That's where scaling comes in. As we discussed earlier, you can partition your data across multiple DuckDB instances.
Creating that mini cluster we talked about.
Exactly. And if you need even more horsepower, you can always integrate DuckDB with a distributed processing framework like Apache Spark.
So there are definitely paths to scale DuckDB if your needs grow. This has been a super insightful deep dive. We've learned so much about DuckDB, its strengths, its weaknesses, and how it compares to those big AWS services. What are some key takeaways you'd want our listeners to remember?
I think the biggest takeaway is that there's no one-size-fits-all solution when it comes to data. DuckDB is an amazing tool, especially for workloads that benefit from its in-memory performance and its ability to handle embedded analytics. But AWS also has a lot to offer with its massive ecosystem of managed services. It really comes down to understanding your specific needs and choosing the right tool for the job.
Choosing the right tool for the right job.
Yeah.
That's a great way to put it. And speaking of learning and exploring, I want to remind everyone to check out productindata.com for more awesome data-related podcasts. They have a really great lineup of content that can help you stay ahead of the curve in this ever-evolving world of data.
I second that. They offer some really unique and insightful perspectives on all things data.
It's definitely worth checking out. Well, I think it's time for us to wrap up this deep dive into DuckDB. But before we go, I want to leave you with one final thought. How could you apply DuckDB to your own data challenges? And would it be a better fit than a cloud-based solution for your specific needs? Keep that question in mind as you continue on your data journey.
That's a great question to ponder. It's been a pleasure exploring this topic with you.
Likewise. And to all our listeners out there, thanks for joining us on the deep dive. Until next time, keep exploring, keep learning, and keep diving deep into the world of data.